Okay, let's talk a little bit about cost function. So now that we know we're going to be building a model to make a prediction, in the supervised learning setting, the way that's going to work out is we're going to have a set of features. So let's call these little bubbles the features. Those are the quantitative inputs to your model. So continuing from the housing example, maybe this is your neighbor's, your neighbor's home price. This is the size of your house, so on and so forth. And each of these features, and this is feature 3, feature 4, whatever. And each of these features then gets input into some model, and then out from that model comes a prediction, right? And then every time you put new features in, you get another prediction out. I want to represent your model's prediction as a vector, right? And a vector is a set of predictions based on individual instances of the features that get put into the model. So let's say this particular instance is 1/4, 1/2, 1/4, 1, something like that. So there's 4 predictions, right? And so in the supervised learning context, we have the prediction, but we also have these realizations. So you have a vector of solutions that you know to be correct, right? And that's how your model gets trained. So let's say it was actually supposed to be 0, 1, 1, 0. And this is a classification problem where the true answers are only 0 or 1. Now, what the cost function's job is, cost function is going to compare these two things. How did what you predicted perform against what actually happened? And so this cost function in this comparison is going to improve the model, right? So the idea is that the model is going to change. Call this delta, right? The model is going to change based on the quality of this cost function, right? And so as the model changes over time, the idea is to improve the cost, right? To improve the mathematical difference between these two things until you get to the point to where you have the lowest possible cost. That is, that you have a model that results in the least amount of error or the least amount of cost associated with making a prediction given your model. All right, so how do we do that? So we need to go into a branch of mathematics called optimization. All right, so a cost function, in order to do optimization, a cost function has to have a very specific characteristic in that it's got to be convex. All right, so convexity is a complicated topic. We won't dig into it. But basically what it means is if we know something is convex, then we can use a set of mathematical techniques to find out what the best solution is. So we want the cost function to be as minimal as possible. So let's say, for example, we've got a cost function that looks like this, right? And so I know that this is the lowest possible cost here, right? So in optimization, what we do is we take an initial guess at the model. Let's say we take this initial guess at the model up here, and our goal is to traverse down this function until we get to the point to where we arrive at the best possible solution. So this method of traversing down the function to get to the best possible solution is referred to as gradient descent. We won't get into the specifics of gradient descent, but just to know that this is how it takes place, right? So that we have some cost function that's convex. That convexity then can be solved through this iterative method where you take an initial guess. The initial guess is then improved until you get to the best possible solution. And then the best possible solution is then used as the model going forward. Now, a couple of nuances here that are important to understand. We're going to, in this basic course, we're going to let the scikit-learn library do this for us, but just to know that this is the case. So when we start to learn more advanced models, it'll be important to you to understand the mathematical nuances of what's taking place here.